Okay, so this is my flat Earth model that I did really quick in Lightwave. It's just a basic model. It's not meant for texturing or accuracy. It's just basically to show the continents and show the ocean. Here's the moon here, and then this light source here is what's going to represent the sun. Now there is some global illumination within Lightwave that I've established, but without any global illumination, it's only to about 10% here. Without any global illumination, it's very difficult to illuminate anything. So I had to use just a little bit of illumination there. So from the top perspective here, we're going to change this to a top view. Here we have the moon. Here we have the flat Earth. And here we have the representation of the sun. I'm just going to refer to it as the sun from here on out. If we take the sun and we move it around, we can view the phases of the moon through the rotations of the sun. So we have an orbit of the moon. I don't want to do that. I want to move this around. We can rotate or orbit the moon around the Earth. We can also do the same, as I showed you before, that we can do this with the sun. Now, if we have the moon orbiting the Earth in 30 days, then the moon is only going to be moving a little bit every day as far as rotational orbit around the Earth. So we can keep it in this spot here, and it's not going to change much from here to this spot here as far as that goes. That's just, we're going to talk about one day, one revolution of the sun. So moving the moon from here to here is not going to affect much as far as lighting. So the problem with this model here is, if the moon is on the inside orbit and the sun is on the outside orbit, and the moon is basically staying in this position for an entire day, then we would see, you can clearly see that as the sun would revolve around the Earth, we would see the phases of the moon every day. If the moon here represented, let's say, midnight, then here it would represent 6 a.m., here it would represent noon, and here it would represent 6 p.m. So if you notice that we have the sun at midnight, and you can see that there's light shining on, this is Europe, this is Africa, and this is Australia. You can see the light shining in these areas here, and you can't really see the light shining as far as what we see in this model here, shining in South America and North America. You can see that the moon here at this point is probably about a full moon, possibly a three-quarter. We're going to go ahead and render this. See, it's more of a three-quarter moon in this area. Well, actually, this is where the camera is. The camera is actually facing right around here, facing up. So here it would be about three-quarters. So you'd probably get about a full moon. And this would be at midnight. Well, then at 6 in the morning, this is going to completely change. So noon, it's going to be completely different. And then 6 p.m. it's going to be completely different. You're not even going to see the moon. It's going to be a new moon. So it's completely gone in the rendering here. So if we go back to noon, here it is at noon. So we would see phase changes every day. The entire change of phases in the moon every day. Now, If we change this and we put the sun on the inside orbit and we take the moon on the outside orbit, then there's a problem as well. You see, we have the sun over here in the Atlantic Ocean here. Sorry, this is the sun here. Now the sun is shining, and if you notice when we render this, the entire surface of the Earth is lit up. Okay? There is no night. We have no night here at all. And what we have is we have the sun here, and if it has enough light to shine all the way to the moon, to light up the moon on an outside orbit, it's definitely going to shine all the way to the other end of the Earth, the surface of the Earth. So that's a problem as well. We can't, you know, as we circle the moon around the Earth, you know, here again, here's our midnight, and we render this and we show the moon. The moon is about 3/4. We go to 6 o'clock in the morning, we render this again and look at that. It doesn't change a whole lot. That's more of a full moon. You know, it's a little off, but it's not that much. This would probably be closer to how things are from what we see of the moon phases. But again, you know, it's fine when the sun is in this position where it's shining on the moon and illuminating the surface of the moon and illuminating this area of the Earth. But when you bring the sun down here, it's illuminating everything, because those rays have to reach from here, from the Atlantic Ocean, all the way to the Pacific Ocean, all the way to the moon. You can't drop the light off here and have it night and then shine it again on the moon. So there's a problem with this. Now, if we take the moon and we move it with the sun, then the moon is rotating around the Earth every day. And if the moon is rotating around the Earth every day, we would keep this same phase as far as from the sun in respect to the North Pole. We would have a phase of a full moon phase facing the North Pole every day. It wouldn't change. Now there are some parts of the world where you would see something different. Like, for example, if you were in Africa here and you looked up at the moon, you would see a half moon. But you would see a half moon at 6 o'clock. Again, here it is at noon, and you would see more of a full moon. So that's a problem as well. We can't have the moon revolving the same time as the sun and the same distance, because again, it would interrupt the phases. It would change the phases. We wouldn't have phases like we see in the moon in a 30-day cycle of phases. So there's a problem completely with all of this, and I really think that this shows that the flat Earth is just not a possibility. There's just no way we could have phases. And on top of that, where would we get eclipses? I mean, why would we have an eclipse? There's nothing to block the sun and the moon. So that's a problem as well. So just something I wanted to share with everybody. I'm just curious as to what your thoughts and comments are. Thanks.